My two guests here. We have Mike Doran, co-founder and president of Aclarus Ozone, and Adam Doran, co-founder and vice president of marketing for Aclarus Ozone. Let's start with a little history lesson, if you will. What's kind of the history of ozone and why it didn't rise to prominence as a disinfectant?
Yeah, absolutely. So ozone itself was first coined in the late 1700s, early 1800s, and it was really created in Europe and started with the first application in Nice in France, and that was really in the early 1900s. And at the same time, that was when the first real application of chlorine occurred in North America. So really at the same time, there's a divergent path. And there wasn't a lot of communication or sharing of the technology or the information at that time. So truly it became widespread in understanding the applications in Europe first before it made its way over this way. But chlorine became so predominant over in this region that's sort of where the divergent paths started back then. One of the big things, obviously, is the sharing of the communication through the cultures of the different people that were colonizing and helping the countries grow. And that's one of the ways that knowledge base was shared throughout Europe first.
Yeah, interesting. So maybe if they had Twitter back then, they'd know about these dueling technologies. And
exactly. Yeah.
So it was more of a fact of just ozone was kind of developed in Europe, chlorine was more developed in the North America, and then that's why it just became the preferred.
And the OEMs started to support it that way too. So now there's proper ozone-specific OEMs like Aclarus that build the suit, and it has to be something that's done right and well designed from the front end. And so that was definitely lacking here too.
Okay. Could you talk a little bit about that, how ozone works, just what that process is, what the setup is? And
absolutely. So ozone is a gas, and it is created from oxygen in the air. So we take oxygen, we can either concentrate it through an oxygen generator process or with liquid oxygen, and then feed it into, typically it's a corona discharge ozone generator. That's the most prevalent and predominant technology for creation of ozone. And we're able to create ozone in a manner that has a certain percent weight in the air. And then we're able to take that and then mix it into a water stream, whether it's water, drinking water, or wastewater applications. But the truth of the reality with the applications of ozone and the equipment is really understanding the infrastructure and in understanding the chemistry so that you're able to provide a solution and provide the treatment. So ozone itself, being a gas, needs to be properly dissolved and mixed in the water stream at the right ratios for the dosing to be able to get the treatment that you're trying to achieve, whether it's drinking water, wastewater, or specialized industrial waters.
Sure. Let's talk a little bit about the chlorine side and what the drawbacks are of chlorine. We'll get to the benefits then of ozone after that, but really want to kind of do this compare and contrast here.
Absolutely. With chlorine, chlorine was a lifesaver back in the day, and chlorine has its application for sure.
It's not going anywhere.
It's not going anywhere. It definitely has its roles, but as we've evolved our education and knowledge about the different chemistries associated with trihalomethanes or byproduct formation or other issues that way, we've understood that there can be carcinogens that can be formed by the use of ozone specifically in surface waters. There's also potential issues. It's predominantly the interaction of chlorine and organics that can cause these carcinogens.
Yeah.
As well, the discharge of chlorine into the environment can cause complications within the waterways, with the natural ecosystems. There's other things associated with the production of chlorine causing the formation of dioxins and pollutants, the shipment of chlorine causing a carbon footprint, and other things of that nature that really cause the evaluation of alternative technologies to really help either lower or put chlorine into an area that's most applicable for its use.
I think it can be much better optimized, right? So having it as applied on full scale on everything else in every application is where it's going to lead to trouble. So for instance, if you have ozone on groundwater and you treat it first with ozone, then you have a little chlorine, your byproduct formation is much lower and the potential for them are much lower. So it's those combinations. So ozone, as another little tidbit here, is it can do a much more comprehensive treatment. So it's not just going to disinfect, it's going to do the oxidation, it's going to do clarification, things like odor, and the speed of which that happens is night and day.
Yeah.
So ozone can do it in a fraction of the footprint in a fraction of the time compared to chlorination.
Yeah, absolutely. And that is one of the big benefits too, is truly the saying is always that ozone works up to 300 times stronger and 3,000 times faster than chlorine in similar applications of disinfection. And one of the big things that really helps there is the reduction in footprint of the systems or the infrastructure associated with that. So if you're looking at a contact time to provide disinfection, ozone is so much stronger and faster in its process that it allows for such a smaller footprint and infrastructure associated with that.
Could you talk? You explained how back in history, ozone kind of rose up in Europe, chlorine in North America.
Yes.
What's the landscape now? How much is ozone being used in Europe still versus U.S. and North America? And
no, it's a great question. One interesting fact I find is that now North America is about 32% of the market share for ozone generators. So it's actually now starting to lead. So there's been a big growth curve with the understanding and introduction and application, and some great companies in North America who's really been the proponents of the education and implementation of ozone. And once we're able to share the knowledge and share the success, specifically organizations which we're proud to belong to, such as the International Ozone Association, sharing that knowledge and sharing that information to help make ozone as a whole more successful in its applications. As well, when we take a look at the full life cycle costs and things of that nature, you can really see the benefit of implementing it. So there's been a practical change in that. But the reality now is that historically, ozone was seen as a fringe technology in North America, where now it is becoming such a more prevalent technology for drinking water, wastewater, industrial applications. As well, in 2019, there's about a $600 million revenue associated with ozone generator sales, and they're predicting about $1.6 billion by 2026. So the reality is that the growth of the market itself is quite large. So the application of that for the technology and for the space is great. And then all the peripheries that benefit associated with the use of ozone, such as downstream reverse osmosis or other treatment technologies that you can put on, ozone can do the heavy lifting, which allows it to be more successful in the implementation and infrastructure.
I think there's been a great combination too of like technological advancements in ozonation combined with a greater knowledge of the impacts of chlorination and chemicals and how they can better be applied. And that sort of timing I think is lining up well. So for instance, ozone used to be bubbled up into a tank where we use slipstream injection that can get 92, 93% into the water. We like to say you can get a lot of ozone generators anywhere, but what it's supposed to do, how it's going to be injected, how is it controlled, and how is it safe, that's where the proper manufacturers come in at us for that.
And I think that was one of the reasons why you see such an uptick now is that the efficiencies and the effectiveness of the equipment over the last even 10 to 15 years has just been exponential, and really understanding and driving down on how to optimize the integration and use of ozone has really led it to be adopted, and you see it growing here so much more in North America.
AOP being a big one. Several states are looking at AOP for water reuse, and ozone's probably one of the strongest, if not the strongest tool.
So that water reuse is really growing in popularity,
Absolutely.
right? And so that's a key way there.
Yeah.
Wanted to also ask about this idea that it's a future-proof solution, kind of a little more of a sustainable path to go down. Could you explain why that phrase is applied to ozone?
Absolutely. For us, what we see, we do a lot of leading-edge research with universities and academia on contaminants of emerging concern and things of that nature. And even as you hear about PFAS and other things coming forward, typically we find that ozone is applicable to a lot of those scenarios. So whether it is pharmaceuticals, pesticides, hormones, or other things like that have a significant impact on our societies and the healthcare systems and things of that nature, we find that ozone is applicable. Research is continually showing that ozone is a very viable solution and option, not just for the disinfection or oxidation of standard chemicals, but in the incorporation with advanced oxidation processes. And that allows for it to really be something that provides the current treatment that you want, but also for those unseen things, or the things that we don't quite fully know yet, such as PFAS or other things, and the lasting effect on societies. So if you're utilizing ozone on a drinking water system, or you're utilizing it on a waste treatment system, you're providing barrier protection to your society and also helping to protect the environment.
Yeah.
You know, I had a couple of big points too, and you know, ozone's come a long way in terms of its treatment ability and where it's known in the marketplace. But where we see a really big opportunity is the expandability, the redundancy, and the ease of use. So the intelligent automation has meant you're not doing chemistry, you're not purchasing, storing, and dealing with chemicals. It's being generated on site, which is always a big step up. But it's that comprehensive ability that it brings to the table, ease of use, but a much smaller footprint.
I was going to say, generated on site, right? So you
Yeah.
don't have all this shipping of some heavy
Or the
kind of
fluctuating
substance.
costs and lack of supply, which has been a big
Right.
issue.
Well, that's one big thing in the last year. I believe it's about a 57% increase in the cost of chlorination. So when you look at life cycle costs or OPEX for utility operators or industrial applications, you can now start to see on a life cycle cost. Ozone is more expensive on a CapEx, but it tends to be more beneficial, especially with the width of the treatment that you're getting over the life cycle cost of an application.
Right.
I have a pool at my house, and I can testify to that price of chlorine basically doubling, even for me, just at that scale. So I can imagine when you're talking about giant utilities,
Yeah.
what those costs went.
I think it's really important to note too that ozone has always been sold as such a powerful tool, but it is a huge enhancement to downstream processes. So it'll help improve membranes, it'll help improve RO, it'll help improve UV significantly by improving the clarification too. So it's a lot of really good pluses for it in this day and age, just in terms of longevity, cost savings, and I mean when you're treating with oxygen and then just putting oxygen out, that's a good thing.
Yeah, and one thing we know is we do a lot of work, and we're very proud of the work we do with the First Nations in Canada, and they are typically in very remote locations. So to be able to provide a system that reduces their needs or dependencies on chemicals and improves the UVT of the water, so UV systems can work better and other systems, and reduce the trihalomethane formation potential, we see such a rewarding application of ozone in those communities as well.
Well,
Yeah.
that's-
One last one.
Sure,
Mike mentioned
absolutely.
the CECs. This we have time. Mike mentioned CECs, and we did a project with McGill University, and we had taken about 86% out with ozone compared to about 6 or 7 with UV. But what we saw was there was a study in 2016, and it's over 320 billion in healthcare costs just in the U.S. and just on endocrine disruptor chemicals. And that's 2016. Europe was about 250 billion on the same year. So that's probably been amplified since then. So that's where we see, you treat today's with disinfection, oxidation, and then the other things coming down the line, be it PFAS or CECs.
And that really is the future proofing. You have disinfection and oxidation generated on site. You can reduce your chemical uses, and it's applicable to a lot of unique chemicals that are just being discovered and studied now in the health effects. So we really think that it is something that everybody should take a look at again. The CapEx is lower, the OpEx is better, the technology is great, and there's a lot of great organizations like ourselves out there willing to provide solutions.
It seems like the uptake will increase even more once that education piece really gets through, right? There's
Yeah.
probably a lot of misinformation, misperceptions around ozone, old information,
It's
right?
and it's expanded beyond just municipal and bottled water. That's another thing. We've done 20 different types of treatments with our system, be it groundwater, stormwater, rainwater. So there's just a bigger branch out there.
Yeah.
Absolutely. And it's really great to see people listening now to all the education and information that's out there. And we appreciate the opportunity to talk about it because this is the way that we can bring light to this technology.
Yeah. And lastly, what is there a difference in uptake U.S., Canada? I mean, you all are based in Canada. Just curious.
question.
Yeah. We feel yes. Right now there is a greater uptake currently in the States, but we're working very hard to bring that into Canada.
Okay, fantastic. Well, thank you for educating me
Travis.
more on
This
this
is great.
topic. Yeah, absolutely, and I'm sure the audience learned a lot too. Both of you from Aclarus Ozone, thank you so much.
Thank you.
Great, thank
Appreciate
you.
it.